Alright, so this is part 2 of the discussion answers video for types of bonds. We just have a couple questions left to finish up here. So number 9, what is a polar covalent bond and what causes this to happen? So a polar covalent bond is a covalent bond in which the electrons being shared are not being shared equally, meaning that they are being pulled more towards one of the nuclei of the atoms than they are towards the other. So we're going to go to our cinch book again to look at a diagram that'll help us talk about this. So this is an example of a polar covalent bond as well as a polar covalent molecule. So in this case we have just two atoms being bonded together in a covalent bond. You can see that these two electrons here are being shared between hydrogen and chlorine. Now in this case you'll notice that this end of the molecule has a partial negative charge and this end of the molecule has a partial positive charge. So this is what we call a polar bond right here, and this is also a polar molecule. Now it's possible to have polar bonds but not have it be a polar molecule, and we'll talk about that in just a moment. So in this case the polar covalent bond is the fact that these electrons, even though on this diagram they look as though they're closer to hydrogen, really in this case how it would be in real life would be that these electrons would actually be drawn closer to chlorine than they are to hydrogen. And the reason that this happens is because of the nucleus. We know that the nucleus is positively charged overall because it has protons and neutrons. So neutrons have no charge, protons are positive, so overall the nuclei of an atom, or the nucleus of an atom, has an overall positive charge. And so that positive charge is attracted to these electrons because these electrons are negatively charged. So there's an attraction between these electrons and this nucleus, and there's an attraction between these electrons and this nucleus. Now if we look at chlorine on the periodic table, we can see that chlorine has an atomic number of 17. So that tells us that it has 17 protons in its nucleus. If we go over to hydrogen, hydrogen has 1 proton in its nucleus. So let's go back and look at our diagram here. And based on those numbers, if we know that there's 17 positive charges in a chlorine nucleus and only 1 positive charge in a hydrogen nucleus, which one of these nuclei do you think is going to pull on these electrons harder? And the answer to that question is that chlorine is going to pull on these electrons harder, because the greater positive charge is going to pull on these electrons harder than the lesser positive charge of hydrogen. So this is a polar covalent bond because these electrons are going to be more likely to be pulled towards chlorine, and thus, because of that, there's a partial negative charge on this side and a partial positive charge on this side. So that's your answer to question number 9. So let's go back to our questions. We have just one more to talk about here. Number 10, how is the polarity of a molecule, not a bond, determined in molecules with multiple bonds? So we're going to take a look at a couple molecules here and talk about this. So remember that the polarity of the molecule could be different than the polarity of the bonds within the molecule. So here we had a polar bond, and thus it also created a polar molecule because there's only 2 atoms involved in this bond. But if we go down a little bit further here, we can start to look at molecules that have multiple bonds. So for instance, this is water. So you've got multiple bonds. You have a bond here, you have a bond here. And so in this case, in order to determine, in this case water is fairly easy because these are also polar bonds, which in this case, because of the shape of the molecule as well, also makes this a polar molecule. Now we're going to go down and look at a couple other ones that consist of polar bonds but aren't necessarily polar molecules. And so for instance, this trichloromethane, which is this molecule right over here, this one has multiple bonds going on. There's a bond between carbon and chlorine here, carbon and chlorine here, carbon and chlorine here, and carbon and hydrogen here. So there's 4 bonds going on, and they are all going to be polar bonds. Okay? And this molecule is also going to be a polar molecule because of the shape of it. You'll notice that all of the the negative polar bonds are going to be over here, and the one positive one is over here. So it does have a positive end and a negative end of the molecule, so that means that it's a polar molecule. Now on the other hand, over here, you're going to see that there are multiple bonds, and they are all polar bonds because you can see the partial charges on all of the chlorines here. So there's polar bonds going on here, but due to the shape of the molecule, there's a partial negative over here, a partial negative over here, a partial negative over here, and a partial negative over here. So the partial negatives are spread out evenly around this carbon, and so therefore overall this molecule is actually a nonpolar molecule, even though it contains polar bonds. Because you'll notice it doesn't have a positive end and a negative end, it's negative all the way around. Whereas this one has a positive end and a negative end. So a polar molecule always has a positive end and a negative end. A nonpolar molecule doesn't have that. And so even though these bonds are polar, the molecule itself is nonpolar in this case. So it's a little bit confusing, and we can talk more if you have questions when I come back. But those are your answers to all of your discussion questions for types of bonds. And I will see you when I get back.